In this lesson, we'll cover graphing exponential functions. An exponential function is any equation f of x that's of the form b, a number, which is the base, to the power of x. So here we call it exponential because the variable is in the exponent. The other requirement is that the base b is either between 0 and 1, or the base b is greater than 1. To see what a graph of an exponential function looks like, let's graph 2 to the x. So here the base is 2. So we're talking about this category over here. I'm going to create a table of values. Let's see. Maybe I'll do like -3, -2, -1, 0, 1, 2, and 3. Might be more than we need, but I'll start with those numbers. Maybe before starting with the negative numbers, I'll start with 0. So what happens if you put 0 into this function? If you do, f of 0 is 2 to the power of 0, and that's equal to 1. So here we have 0, 1, and that's this point right here. If we do 2 to the first, so evaluate the function at 1 to the first, well, that's equal to 2. So at 1 you get 2 back. So at 1 you get 2. It doubled. If we check, let's see, moving on to, well, what's f of 2? That's 2 squared, and 2 squared is 4. So here we get 4. That's the point 2 comma 4. This thing doubled yet again. And probably no surprise if we look at f of 3. That's 2 to the power of 3. 2 cubed is 8. 2 times 2 times 2. And so this is 8. So we get the point 3 comma 8. That's right here. So between these points, it looks like the graph is moving upward. So it's like increasing faster and faster and faster. Now, what about these negative x values? So let's start with, I guess, maybe what's f of -1? That's 2 to the -1. A negative exponent means you take the reciprocal of that number. This is really a half, or if you'd like, 0.5. In either case, at -1 you get 1/2. So that's right about there. If you check -2, so this is 2 to the -2 power, that's 1 over 2 squared. So again, the negative exponent puts the base into the denominator, and it makes the new exponent positive. So 1 over 2 squared is the same thing as 1/4. So kind of running out of room to write this, but that's about there, -2 comma 1/4. And the thing to note is here it goes 1, 2, 4, 8. Here it goes 1, 1/2, 1/4. So this last one, f of -3, that's 2 to the -3. That's 1 over 2 cubed, so that's going to be 1/8. And at this point, it kind of like, disappears a little bit, but, it's right about there. I'm now going to draw in the equation that goes between these points or through these points. And that looks something like this. Not a perfect sketch, but this is the idea. And as we move in this direction, the graph is getting smaller and smaller and smaller. But I'll just put this arrow to indicate that's the general direction that it's going. A couple of things to point out about this type of function. If you have an exponential function like this one here, a base to a variable, and the base is greater than 1, your function is going to increase. And we can see why in the table of values. The second thing is, because these numbers keep getting closer and closer to the x-axis, we say that the x-axis is an asymptote. So let me write this off to the side. I'll define this term asymptote. An asymptote is any line the graph approaches. So here, if you look at the x-axis, which is the equation y is equal to 0, it is a line, and the graph keeps getting closer and closer and closer to it. And the term we use for that is asymptote. So exponential functions will have this feature. This one increases. Let's take a look at a decreasing exponential function. So for this next one, f of x is equal to 0.5 to the power of x. Here we have the base, b, it's equal to 0.5, and that's definitely between 0 and 1. In this case, it's going to turn out our exponential function will decrease instead of increase. So let's check out why. I'm going to make a table of values. Maybe I'll do fewer than last time. Maybe I'll just do, -2, -1, 0, 1, and 2, and we'll see what we get. Let's start with, again, I'll go with the 0, 1, and 2. I'll start with those first. So to start with, what is f of 0? It's 0.5 to the 0 power, but that still is equal to 1. So at 0, we still get 1, and that's that spot right here. And if we look at f of 1, so that's 0.5 to the first power, but that's just 0.5, or a half if you would like. And that means at 1, we get this point here. So the graph is definitely decreasing. It looks like it's going down. And if we check f of 2, okay, so that's 0.5 squared. That's 0.5 times 0.5. That's 0.25, which is the same thing as a fourth. So that's like right about here. So it looks like the graph is moving downward. And that'll continue as we go in this direction. So again, we get another asymptote here. Y equals 0 is going to be an asymptote for this function. We'll plot that in a little bit. Okay, what about -1 and -2? Let's check those out. F of -1, that is 0.5 to the -1 power. That's 1 divided by 0.5. And 1 divided by 0.5 is 2. So at -1, we get 2. I'll check one more spot. F of -2, that's going to be 0.5 to the -2 power. That's 1 over 0.5 squared. And that's 1 divided by a quarter, which is equal to 4. So at -2, we get 4. Now this trend is going to continue. As we move in this direction, it's always going to be half as much. And if we go backwards, it's always going to double. So I know we're also going to get -3 is going to be equal to +8 if you want to include that point as well. But if I sketch in the graph around these points, it is exponential, but it's not increasing, it is decreasing. So I'll put an arrow here to indicate that trend continues. This one gets closer and closer to y is equal to 0. So again, we have that y equals 0. This line is an asymptote. And if you want to be more specific, you could actually say it's a horizontal asymptote because this is a horizontal line. In example 1, let's graph the exponential function f of x is equal to 2 to the x plus 3 plus 4. Now down here, I already have the graph of f of x is equal to 2 to the x. And if I want to sketch this graph, I can use transformations to do so. So that is, well, instead of an x, we have an x plus 3, and there's also a plus 4 at the end. So there are two changes in this function. First, the graph is going to go left 3. So because of the plus 3, it's changing the x's, but it'll have the opposite effect. And then this plus 4 is changing the y's, so it's going to go up 4 places. So every point on this graph will go through these two steps. But not only the function itself, but the asymptote. So just to remember, the asymptote of the equation 2 to the x is y is equal to 0. So this horizontal line is going to follow these two movements. So let's actually graph that first. It'll be nice to have it as a guide. So if you take this entire line and first move it left 3, that does not change the line at all. You take any point and move it 3 places to the left, it goes forever in both directions, so it's the same exact line. Now up 4, that completely changes this, the y value. It's not at y equals 0 anymore, but it's going to be at y is equal to 4. So let's make a note of that. The asymptote on this new graph is at y is equal to 4. So I'll sketch that in with a dashed line. This means that, well, this new function has to approach this asymptote. Okay, to complete the sketch, I'm going to move a couple of points. Like maybe I'll pick 3 points on the function to move. So this is a good one to work with. The point 0, 1 will be another good point. Maybe this point here. That's the point 2, 4. And maybe one more. Maybe this one here. That's the point -1, 1/2. Okay, so I'll start with this point here. It first goes left 3, 1, 2, 3, and then it goes up 4, 1, 2, 3, 4. So this is the new location of the point. That's at -1, 8. That's the new point. Okay, this one, same idea. It goes left 3, 1, 2, 3, and then it goes up 4, 1, 2, 3, 4. That's right here. And this last point, again, goes left 3, 1, 2, 3, and it goes up 4, 1, 2, 3, 4, right about there. And I think that's enough to get a sketch of this new equation. Okay, it has to go through these points. I know it's increasing, so it's going to look like this. And at the same time, it also approaches the horizontal asymptote. I think I'll include one extra thing in this problem, and that is the domain and the range. The domain and the range of the original function are all real numbers for the domain, and the range is all positive y values from 0 to infinity. The new graph has a domain of all real numbers because it goes forever to the left and to the right, so that's my domain. I'll put that as from -infinity to positive infinity. But the range is going to be all y values that are greater than 4 because this is where the graph levels off. And for that reason, the range is going to be from 4, not including it, to infinity. There's one specific exponential function that's worth focusing on, and that's the function f of x is equal to e to the x. So here, e is a number. It's 2.71828 approximately, but it goes on forever. So in a lot of ways, it's like pi in that it's irrational and it goes on forever, and so we use a symbol to denote it. It has a very formal definition. This thing here, you don't have to know this, but it's the limit as n approaches infinity of this expression. If you go on to take calculus, this number is very important, and you will discuss what this definition means and where it comes from. But in this class, all we need to know is that there is this number, e. It has an infinite decimal, so we denote it with this symbol, and it's roughly 2.718. So I graphed the function over here. This is a graph of e to the x. Maybe I'll just note a couple of things about it. The base is e, which is bigger than 1, and so if you look at the function, it is increasing. A lot like 2 to the x, but it's e to the x. And if you look at 0, x is equal to 0, you get the y value of 1, which that's not really a surprise because in this function, if you put 0 in place of x, that's e to the 0, and well, any non-zero to the 0 power, we define it to be 1. But if you look at 1 and you put that into this function, e to the first power is actually just e. And so here at 1, this is the y value, and it's about, 2.7 is where it's located. It's greater than 2, it's less than 3, it's right about there. So it's increasing. It still has an asymptote. The asymptote is y is equal to 0, so that's not different. And if you think about the domain and the range, the domain is all real numbers. The graph goes forever in both directions on the x-axis. But the y values are greater than 0, so the range is from 0 to infinity. So that's all you really need to know about this function is if you graph it, you get this increasing exponential function, and it has a lot of the same features as a graph of 2 to the x. So with all that being said, can we sketch a graph of the function f of x is equal to e to the x minus 2 minus 1? What does that thing look like? Now here, I already have a graph of e to the x, so let me just make note of that. So here's f of x is equal to e to the x. How is this equation different than this one? So again, I'm looking at this function, I'm saying, oh, well, there's two changes. For starters, here we have an x minus 2 in the exponent instead of just an x. That's changing the x values. It'll be the opposite of what I expect. So it's going to go right 2 places. Now this minus 1 is changing the y values, so it's going to go down 1 place. Since the horizontal asymptote is currently at 0, here, if you go right 2, that's not going to change y is equal to 0 as the asymptote. But going down 1 will. It's going to move it down 1 place here. So the new asymptote is going to be at y is equal to negative 1. So that is the asymptote. Now, if we want to graph this thing, we just have to move a couple of points around. So let's see. I think an obvious choice would be this one. I'll move the point 0, 1. There aren't a lot of other nice numbers to choose on e to the x, but this one I think will work well enough. This is 1 comma e, so about 1 comma 2.7. And I guess if you want a third point to move, maybe this one here. At x is equal to negative 1, you get 1 over e. So these points were, that was 1 comma e, because if you put 1 into this function, you get e to the first power, which is just e. I also chose 0 comma 1. That makes sense too, because if you put 0 into this function, you get e to the 0, which is 1. And then I also chose at negative 1. If you put negative 1 into this function, you get e to the negative 1. But e to the negative 1 is the same thing as 1 over e. So a negative exponent places it into the denominator. So let's move these 3 points. So I guess starting with this one here, it's going to go right 2 places, 1, 2, and then it's going to go down 1 to here. So this is the new location. That's at 3 and then about 1.7. So that was 3 and then 1.7, so like roughly there. This point will be nice to move. It goes right 2 and down 1. So that's here. That's the point 2 comma 0. And then lastly, this one is going to go 2 places to the right and then down 1, so roughly there. Okay, we're now ready to sketch the equation that goes between these 3 points. So it's going to increase like this. And then it's going to approach the horizontal asymptote. Maybe just to state the domain and range, just to complete this. For the new function, the domain is all real numbers. This arrow indicates that it's going this way forever. It's going forever both to the left and to the right. But the range is from negative 1, not including it, to positive infinity. And the reason is this is the lowest y value. It never reaches it. That's why we don't include it. But the graph is moving upward, and so you get everything going to infinity.